Hello everyone and welcome to your P3 notes, or your prerequisite notes. Today we're going to be talking about radicals and rational exponents. So we're worried about how the exponents work, how we can do it with fractions, and following basically the same rules we did last time. So you should have your P3 notes in front of you and ready to go. All right, when you look through here, we're going to evaluate square roots. So that's just a simple, not a cube or anything fancy in it. We're going to simplify expressions of the form square root of a squared. We're going to use product rule and simplify square roots and the quotient rule. So these two kind of go together. We're going to add and subtract square roots. So when do they have to be the same and when can we do that? Rationalize the denominators because denominators cannot have square roots in them. We're going to evaluate and perform operations with higher roots like square roots, cube roots, and so on. And we're going to use the rational exponents. Here we go. So the first ones are just explore. Let's see what you remember. So write down your answer and come back and check. The square root of 81. I'm hoping you remembered that was generally plus or minus 9. Now in this book, if they do the square root of 81, they really just want 9. They're not going to do the plus or minus. If they want the minus, they're going to make it look like this. So the square root of 9 is 3. Negative means they want that negative answer of that square root. Here you have to add first. So you should have said, hey, that's the square root of 100. The square root of 100 is 10. If you use your plus or minus, that's okay. But right now, that's not technically what they want. So now the square root of 5 squared, well, the square root cancels the square, because if you remember, that's really 5 squared. And the square root is the 1/2 power. And then 2 times 1/2 is 1. So the answer is 5. Or the square root of 25 is 5, either way. Square root of negative 5 squared, well, again, you're going to square the negative 5 first, which makes that a positive number. So the square root of that is, again, 5. They don't want the plus or minus. Okay, when you're multiplying, we're going to go through here. We have a square root times a square root. So I can either do these separately if that's easier for me, or I can do them together, whichever one makes more sense. So try the bottom two, and let's see how you do. Okay, if I would have done this, I would have said 75. Hey, I know a square root in there. That's 25 times 3. Well, x cubed is really, there's a square root in there too, an x squared times an x, right? So the square root of 25 is 5. The 3 does not have a square root, so that stays inside of my radical. The square root of x squared is x, so that one comes out, but this guy does not have a square root, so he stays inside. All right, this one here, there's two ways to do it. You could look at this and recognize that 10 is 5 times 2 times your x. Well, now I've got two 5s. So that's the square root of 25, basically. So that will come out. I have two x's. So the x will come out. And what's left inside the radical is the 2. One option. The other one is to actually multiply them. So you get the square root of 50x squared. Well, 50 is 25 times 2. Square root of 25 is 5. Square root of x squared is x. And the 2 stays inside your radical. Either way, you should get the same answer. Both methods are perfectly acceptable. Division, I can reduce first and then do my radical, or I can separate them out if they don't reduce. So when I look down here, I would like you to try both of these and see how you do. Well, this one, since they don't reduce, we're going to separate these out. So this is the square root of 75 over the square root of 16. Well, 75 we know is 25 times 3. So this is 5. Square root's a 3. And the square root of 16 is 4. And you are complete. Down here it would be easier to put them together so I can reduce first. So we have 150x cubed over 2x. Well, this reduces here to 75, and this reduces to x squared. So now I'm taking the square root of 75x squared. Well, we just did 75 up here. So we know that that's 5, square root's of 3, and the x comes out. Completed. I hope you did well on those. Okay, next one. In order to add, square roots work kind of like variables. They have to be the same, and then we can add or subtract their coefficients. Well, 13 and 52 are not the same, so we have to see if we can get them that way. Well, 13 is prime, so I know there's nothing I can do with 8 square roots of 13, so he just stays. Well, let's see what we can add. Well, 52, not sure what goes in there. Let's try a few things. Let's try, I know 2 will go in there. 2 and 26. Well, that's not helping me out. Well, 26 I know has a 2 in it. 2 and 13. Oh, I have a group of 2s. So I could have said 4 times 13, and the square root of 4 is 2. And then I have to take the 2 times the 9, which gives me 18, and I'm left with a square root of 13 inside the radical. Since both of these are square roots of 13, I can combine the 8 and the 18. So I have 8 square roots of 13 plus 18 square roots of 13, which means I have 26 square roots of 13. I can add them because they are the same. Okay, if you didn't get that right, pause and try yours again. So 12 we know is 4 times 3. Square root of 4 is 2, so we got 2 square roots of 3x. If you did that as 2 and 6, you would have got 2, 2, and 3 still, and you still would have found the 2's. 27, I know is 3 and 9. Well, I know 9 is 3, but just in case you did something different. So now I know the 3 comes out, but I have to take the 3 times that 5, which gives me a negative 15, and I also have a square root of 3x left inside. Since they are the same, I have to take the 2 minus the 15, which is a negative 13, square roots of 3x. Hope you did better if you messed it up the first time. We like mistakes. They work really well. They help us learn. Rationalizing the denominator. You cannot have a square root in the denominator. Someone made this rule up. It was a long, long time ago. Okay, before we do this problem, I'm going to reduce it because I know that 2 and 6 reduce to 1/3. But these are the same radical. So that means I can reduce these, and these x's are going to cancel. So I have a square root of 3 in the numerator and a square root of 5 in the denominator. The square root of 5 is what we cannot have. So to get rid of it, you just multiply it by itself, because the square root of 5 times the square root of 5 is technically the square root of 25, which is just 5. So my denominator becomes 3 times 5, which is 15. But whatever we do to the denominator, we must do to the numerator. So now I have 1 times the square root of 15, which is just the square root of 15 in the numerator. You cannot reduce these because one is in a radical and one is not. All right, we're going to use this same concept with what we call conjugates. So your problem starts here. It will look like 3x square root of 5 plus x. I cannot have this square root. To get rid of it, we multiply by the conjugate. So you have to remember the conjugate, you also used these with i's last year, is opposite sign. So it's the square root of 5 plus x. Its conjugate is the square root of 5, and you just change the sign, minus x. The reason we do this is when we're going to work with this denominator first. When you take the square root of 5 times the square root of 5, you get 5. Well, here I get a negative x square root of 5, but here I get a positive x square root of 5. So those two are going to cancel, and then I just have my last term, which is minus x squared. So I've effectively cleared the square roots out of the denominator. The numerator, since nothing is going to combine here, we just flip that. That's 3x times the square root of 5 minus x. So your final answer is 3x times the square root of 5 minus x all over 5 minus x squared. My line did not draw. All right, this is not a difference of squares, so it cannot be factored, so you are finished. Try yours. You should have gotten the conjugate is the square root of x plus 7, but you also have to do that in the numerator, so square root of x plus 7. You do not have to show that middle term. I'm going to go down here a little bit. So square root of x times the square root of x is x minus 7 did not get my square root on. Square root of 7 times 7 is just 7. And then your numerator does not simplify, so we leave it alone. Square root of x plus square root of 7. And you are done. All right, now we're going to go a little bit higher than square roots. So we're just going to start with a simple cube root. And it's the same process of a square root, except now instead of looking for groups of 2, you're looking for groups of 3. So pause and try these. Let's see what you remember. So 40, you know, is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. I have 2 cubed right here. Well, the cube root of 2 cubed is 2. And 5 does not have a cube root, so that goes here. If you do not put the 3 on this ledge, that stands for square root, and that is wrong. So do not forget your index. Now let's look here. We got a negative 125 and 27. They don't reduce, so we're going to do this separately. So I'm going to take the cube root of negative 125 over the cube root of 27. Well, I know 27 is 3 cubed. So the cube root of 3 cubed is 3. So my denominator is 3. I'm hoping you know that 125 is 5 cubed. If you do, you could just put down a negative 5. If you do not, then you need to factor tree that out. The reason we can do this is negative 1 times 5 cubed, and the cube root of negative 1 is negative 1, which is just your negative that you bring out. When you're looking at this here with fractional exponents, the denominator is your index on your square root. The m is to what power you're taking it to. It can be written either way. On the outside of the parenthesis or the inside of the parenthesis, it means the exact same thing. We just use the one which works best for us. If it's negative, it follows the same rule. It belongs in the denominator. So when I'm looking at this and I want to evaluate, and you're not supposed to use a calculator, this really means 27. Okay, now I'm going to do the cube root of 27 to the 4th power. Well, if I put the 4 on the inside, I don't know 27 to the 4th, but I do know the cube root of 27. And then I can take that to the 4th power. So the cube root of 27 is 3, and then 3 to the 4th is just 81. No calculator needed. All right, let's go down here. Multiplying a little bit different here. So I got 2 times 5, which is 10. But now I have to add these exponents. This is x to the 4/3 plus 1/2. So to add exponents or to add fractions, you're technically finding a common denominator. Hoping you remember. So this guy we have to multiply by 2 and this one by 3. So my common denominator is 6. So now I've got 10. X is over 6. Well, this is 8. Whoops. And 3, which is 11. All right, that's kind of okay, but if you look at this and I rewrite this, 10, now let's write this in radical form. X, this is the 6th root of x to the 11th. Well, when I look at that, I have at least one group of 6's in here, because this is really x to the 6th times x to the 5th, right? Well, the 6th root of x to the 6th right here is x to the 1st. So that one belongs on the outside of the radical. 5, I don't have a full group of 6, so that has to stay inside, and that is your final answer. Good luck. I hope you do well, and if you have questions, make sure you're posting them.